Assalamualaikum warahmatullahi wabarakatuh. Thank you for joining today's presentation and glad to see you all. In this opportunity, I would like to present my final project research, and the title is Optimization Time and Cost Full Stack Project Using Time Cost Trade-off Method. Before I begin, let me introduce myself. My name is Balqis Rahmi, Diploma 4 in Design and Manufacture Engineering Study Program. From this point, I want to begin with first session about the background, and I will explain about the background of the problem. Project can define as activity that takes within an occur limited period of time for produce product with a good quality. Whose quality criteria have been clearly outlined by Suharto 1999. There are cost, timeline, and quality. Time and cost have a very interrelated relation. Sometimes the fabrication process took a long time, which can increase a project cost. Engineering, procurement, and construction company in Karangpilang got full stack project order. But in the execution, the project have a delay and make PT XYZ got the consequence as pay a penalty. The delay causes by various problems such as decreased productivity, high load production, ineffective working time, and so on. Because the company runs several projects at one time, the delay at this project can affect the other project. For this reason, it's necessary to plan and reschedule the project, so the risk can affect the other project and can receive to the client on time. The problem can be solved using time cost trade-off method, which can be used to optimize time and cost by minimizing the cost. This is a bar chart comparison about the actual and planned schedule of the 2019 full stack project. The project starts on 10 September 2019 until 18 May 2020, but the actualized delivery on 28 August 2020. From this background, the formulation of the problem as follows. The first is what activities can be accelerated on full stack project. What is the optimum time and cost accelerating the full stack project? And the third is how does the S-curve of the full stack project compare between before and after the acceleration. The purpose of the result is first, knowing the activities on the full stack project that can be accelerated. Second is knowing the optimum time and cost result from the acceleration of the full stack project. The third is knowing the comparison of the S-curve of the full stack project based on the acceleration schedule between before and after the acceleration. Based on the research objective has been mentioned, hope that the result of this final project can provide benefit and contribution for students as learning material in a project to find out how to optimize time and cost project using TCTO method. And for company can be used as a benchmark for working on other or similar project and able to apply TCTO method in order to obtain efficient time and cost. This is the research delimitation. The first is discussion was only conducted on one project. There is full stack project. Acceleration is only doing in fabrication and packing process. Operational machine condition is considered normal. Compression by using alternative increased work hour and manpower. Unit price doesn't change during the project. Addition of overtime and salary in accordance with government rules. And calculation are carried out using Microsoft Excel and Microsoft Project software. Uh, the research of the method is first is start, then problem identification, field study, and then data collection. In data collection, there are project information, schedule plan, budget plan, and weekly report. The next is arrange work breakdown structure, arrange network planning, calculation and analysis critical path, and then TCTO analysis. If the time and cost optimum, the next is make X curve. But if the time and cost not optimum, back to TCTO analysis, and then conclusion and suggestion and finish. Next, I will explain about the result on my final project. First, I will describe about the project generally. A full stack project owned by electricity company located in Lombok. The project delay for 103 days from the planned schedule. The details about the structure project in the study are shown in the following slide. The next is arrange work breakdown structure. This is the work breakdown structure for the full stack project. Next is arrange network planning. After knowing the work breakdown structure of the full stack project, the next step is arrange the sequence of activity with a dependency relationship between activity based on schedule plan and actual schedule. The next is forward and backward pass. This calculation used to determine the critical path. The forward pass, the value of ES or early start, and EF early finish or the fastest time to complete an activity. And the backward pass is the value of latest start and LF is latest time to finish. After that is calculate the slack ES minus LS or EF minus LF. If the result is 0, it means the activity is critical. This is the critical path of the full stack project. The red color is critical activity and the black color is non-critical. Next is crashing with alternative adding overtime. This alternative using 3-hour overtime. For the standard week for overtime is used government rules. The first time overpay is 1.5 times hourly salary, and salary for every subsequent hour of overtime is 2 times the hourly salary. This is the crashing with alternative adding manpower. According to the Suharto books, in adding manpower, there is a correlation between the manpower, the area of work and productivity. This graph is show if the manpower increase, the productivity will decrease. The first is we have to know the ideal work area. I use the average of 100 and 200 feet meter per tenaker, and the result is 13.935 meter square per tenaker. After that, we can find the amount of ideal manpower from the area of work. For knowing how many manpower that use is with assumption 25%, 50%, 55%, 100% of additional manpower. This is the additional worker. For assumption 25% and 100% manpower cannot be used because the additional worker more than the ideal worker in several activities like roll, assembly ring, blasting primer, assembly segment, and finish painting. From the formula, we can show the crash duration and crash cost in the table. This is for adding 25% manpower, and this is for adding 50% manpower. The next step is shorten the activity period, starting with critical activities that have the lowest cost slope. From the table is found for the additional overtime. The normal duration is 262 days, becomes 207 days. And for additional 25% manpower, for normal duration is 262 days, becomes 208 days. And for additional 50 manpower, the normal duration of 262 days becomes 188 days. This is the total cost for actual duration and crash duration. For the direct cost is covered total cost direct labor and material cost. And for indirect cost, covered a total of indirect labor, consumable cost, operational machine cost, and other costs. For the alternative 25% manpower and adding overtime, it's not calculated because the duration crash is not fulfill the planned duration. For more details in the section of determining the optimum time and cost. This is the calculation of the total cost and the cost comparison based on the calculation of direct and indirect costs have been calculated previously. It's known that the total cost incurred in the normal duration are 4,403,369,400 rupiah. Then in the accelerated duration with an alternative adding 50% manpower is the total cost is 3,805,459,099 rupiah. So that there is a reduction in cost of 597,910,301 rupiah, or decrease 13.58%. Determine optimum time and cost. So to achieve the optimum time using alternative addition of adding 50% manpower. This is because the duration of crash at the additional 50% manpower is close to the planned duration. So that it can accelerate the project activities. The total cost incurred in the alternative of adding 50% manpower also decreased 13.58% from the total cost on the actual schedule, or the difference was 597,910 rupiah. This is the S-curve of the project. The S-curve for the acceleration schedule, or the blue curve, can be complete faster than the actual duration, because a more sloping line indicates a greater progress of work each week. This is the conclusion and suggestion. The first, for conclusion is activities that can be accelerated on the full stack project are marking cutting, roll assembly ring, blasting primer, assembly segment, and pre-assembly, finish painting, and packing. From the calculation result, it is found that the optimal time and cost with alternative of adding 50% manpower because the resulting duration is less than the planned duration or 189 days, with the result of crash duration is 188 days. The cost amounted to 3,805,059,099 and there was a decrease of 30.58% from the actual duration fee. The comparison of the time and cost of the full stack project using the X-curve, it is found that the schedule with the accelerated duration can be more complete faster than the actual duration because the more sloping curve line indicate the progress each week is greater. The suggestion is project scheduling using PDM is highly advised for overlapping project activity, and in the future, if the company gets the same project order, this research can be used as a evaluation suggestion or consideration in order to avoid project delays. Thank you for your attention.